Suppose I have a water tank and the level of water in this tank is, suppose, x. This height is x, and suppose observer is sitting here. Suppose observer is sitting here. Okay, that is observer. This is observer sitting here, and the distance of observer from the liquid surface is, suppose, y, and a coin is placed here. So the apparent depth observer sees at a depth of, that is apparent depth, suppose that is h apparent. H apparent will be the refractive index of medium in which observer is sitting. Suppose that is mu1, and the refractive index in which the coin is placed is, suppose this is mu2. So apparent depth will be equal to mu1, that is the refractive index in which observer is sitting, mu1 into the length of medium in which observer is seeing is y. So y divided by mu1 plus x medium of length of medium in water, that is x divided by refractive index of water, mu2. Okay, suppose if observer is sitting in water and looking at a bird, suppose this is a bird and observer is sitting water, it is sitting here, this is observer, and the length of water medium is x and length of air medium is y. The refractive index is mu1, refractive index is, suppose, mu2. So observer is sitting here. So in this case, h apparent will be mu2 because observer is sitting in water. So this is the refractive index of observer medium into x divided by refractive index of length x plus y divided by refractive index of y. Okay, so this is the formula we will use. So I have a question. This is a question I have. A bird in air looks at fish vertically below it and inside water in a tank. If the distance of the fish as estimated by bird is h1 and that of bird as estimated by h2, then the refractive index of liquid is. In this case, a bird is sitting in a tank. Suppose tank is full of water. Okay. Here is bird sitting here. This is bird and this is suppose fish. And the distance the bird sees at what distance? If the distance of the fish as estimated by bird is h1, so h1 it is apparent distance. So h1 is equal to by bird. So refractive index of air is approximately 1. So 1 into, if this distance, the actual distance is, suppose this is x. So this will be, this distance is 0. So 0 plus x by mu. This is mu. Okay. Now h2 will be, now h2 will be mu into mu into x by mu. Okay, this is equation 1, this is equation 2. So using 1 and 2, using 1 and 2, if we divide 1 divided by 2, then we will get h1 by h2 is equal to, this mu and mu gets cancel out, x and x gets cancel out, so this will remain 1 by mu. This implies mu is equal to h2 by h1. This will be our answer.